Hey everyone, today we are going to start one of my favorite topics of this entire course, and that is simulation. What is it and what is it used for? If you haven't noticed, to this point we have worked with very static models. They're built one way, doing what-if analysis. The best we can do is sensitivity analysis. But in reality, most of the things we do are governed by statistics, averages and means and distributions and random behavior. And that's exactly what we're going to do here. We are going to be building models that no longer use linear programming, but allow us to simulate the real world to get an idea of what may or may not happen. To get started with that, we're going to be using a lot of random numbers. You'll see I have a lot of things going on here. I have different distributions, all these kind of things. We do have different distributions we follow that are used in different cases. The number of wins in so many trials, discrete numbers, time between events, bell curves. We also have multiple different distributions here. I'm going to clean this real quick, and we're going to start right here with the rand function. You'll see in Excel, rand is the key random function. It generates a continuous uniform random value between 0 and 1. You'll see these all look the same. Why is that? Well, I went to my Excel preferences. I went into calculation, and I turned my calculation options to manual, and I unchecked recalculate the workbook before saving. Why would I do this? Well, we're getting to the point where we're going to have lots of random numbers and there's going to be lots of recalculation. So instead of having tens of thousands or hundreds of thousands random numbers regenerate and calculations run, we only want those to run when we ask Excel to do so. So from this point on, we'll turn this to manual. This will let us save it without recalculating. And anytime we want them to recalculate, we're just going to go ahead and press F9. There we go. You'll see I have all those nice things. Now the other thing I'm going to do, I will be providing you with a file. You can go to your Excel add-ins again. You can go to Browse, and I will be providing you this rng.xla file. Once you select it, you just check it, click OK, and click Enable Macros, and all of a sudden you will have some new functions. Right? For instance here, you will have Rng binomial, which takes a number of trials and a probability of success. So I can put this in here. Rng binomial, number of trials, let's say it's 10, with a 0.4% or a 40% chance of success. I can recalculate on this, and it tells me how many times I win. I may want a discrete uniform, right? And you'll see here, Rng discrete uniform, min and max. So I can go in here, I'll say I want a discrete uniform value between 0 and 10. And we should get exactly, oh, I forgot the equal sign on this. This is what happens. Put that equal back in there. Get that discrete uniform. Press F9. Watch it recalculate. You might have continuous uniform. And let's just use the Formula Explorer here. You'll notice I can click this little button. It brings this up over here. Let's see. We have a lot of Rng functions now. You'll see discrete uniform. This is exactly, well, discrete uniform. Uniform is my continuous uniform. So I'm going to go ahead and use this here. You'll see it just needs a min and a max. We'll do again 0, 10. Fantastic. We also have our Rng normal. So I'm going to use the Rng normal here. Rng normal, you'll see, takes a mean and a standard deviation. So we'll do a 5 with a standard deviation of 2.5. Clean that up. And all of a sudden, you'll see we have lots of random numbers. We can do lots of things that we want to do. And we can plot these. We can work with them. We can use them however we want. All these random numbers will use different types of behavior. You will see, and they will be very useful as we go on. So to start, let's start with a static healthcare example. We have a company that has 18,533 employees. They have an average insurance claim per employee, an amount contributed for insurance per employee, and they're assuming some monthly increases of 2% and 1%. So how do we do this? First, we lay out a time periods we're looking at. So here we have 12 months. We also define a process, right? So this is much like the inventory or multi-period examples we've looked at before. We start with the number of employees, the employee contribution, the average claim, the total claims, and then the cost to the company, and then we go through period by period. So for instance, my number of employees should be very straightforward at this point. it is going to be my original number of employees plus my rate of increase times that same number of employees, 18,903. Okay? We can look through this, and we know in the second period, I'm not going to be starting with the same number of employees. I'm going to be starting with the number of employees from the first period, so we can just drag those down there. And all of a sudden, we have a nice little formula going on here, and you'll see each one depends on the number of employees from the previous and increases by 2%. My employee contribution in the first period is my number of employees times my amount contributed per employee. That gives me 2.3 million. We also are going to assume here that my employee contribution, right, stays the same because, well, it normally does. This is how paychecks work. Uh-oh, I made a mistake here. Oh, I should have locked a value that I did not lock. So let's go ahead and lock that and drag that back down again, and we can even recalculate. Great. Average claim per employee, right? We are going to start the same way. I have my average claim per employee plus my average claim times the rate of increase. I'm going to lock that. There you go. So 252 going all the way down, continually increasing. Oh, I must have made a mistake there somewhere. Oh, I sure did. Because here, that's not the value I'm looking at. I want to go back and look at my value from the previous period. We're always increasing over the previous period, so my first and second periods are different. Okay, there we go, all the way up to 281. My total claims is my average claim per employee times my number of employees. Very straightforward. And my company cost is the total claims minus the employee contribution. Bring those down. Right there, you'll see that's my sum. I can hit F9, and I get this beautiful model that has just added everything together. So what are the problems that I have with this? Well, it's a static model. I can't see what happens if the number of claims goes up or down. It's always assumed that my total claims and my average claim only go up. It assumes that my company is always growing and growing forever. So these are things I have to deal with. And to do that, we will move on to our next example in our next video, where we will introduce random behavior into this model. Go.